Hello, my name is Bram and today I'd like to talk about some Subaru cylinder heads. I'm going to be explaining the differences between the B25 heads, D25 heads, and also run down on some of the porting changes I've made to these new set of D25 Subaru heads. Firstly, I'd like to discuss the differences between the B25 heads and the D25 heads. The primary difference between these two heads is going to be the combustion chamber volume. As we can see on the B25s, there's a steep angle up inside the upper corner of the combustion chambers, and on the Ds, that area is quite rounded. This results in a different combustion chamber volume and also a different compression ratio when all else is equal on a Subaru motor. From memory, I believe the Bs are around a 56 cc's combustion chamber, and the Ds are somewhere less, I think 51. This could be incorrect. I haven't cc'd them just yet. The other differences in the design is going to be the webbing of the water jacket and the casting of the coolant passages through the head. You see there's small openings here, and it's also deeper down inside compared to here. There are slight differences with structural webbing on the intake flange, under the intake flange. It's not on the Bs, but on the Ds it does. And the other primary difference is also going to be the Ds have there are passageways on the exhaust ports inside the bowls. They all link up and they come out on the rear of the head to there's a flange, and that would typically be used for a secondary air injection system. The B heads don't have that, the D heads do. There are other variations of EJ25 heads. Right here I have an old V25 head. If we're looking at this one, we can see that it has the sharp angled combustion chamber like the Bs, but it has the water jacket castings like the Ds. And if you actually look down inside there, it even says D, even though it's a V25 head. The other difference is, unlike the Bs, the Vs have the secondary air injection ports, into the exhaust port bowls. There are also, I believe, W25 heads, which are the dual AVCS. I don't have any of those here with me, but for the main part, we're just going to discuss the differences between the Bs and the Ds. Looking into the top of the cylinder heads, we can see other subtle differences. The Bs have half moon caps, which are basically where they've machined out the tunnel for the cam. Part of the manufacturing process must have needed that part machined out, and they've capped it off with what is known as a half moon, so that when the rocker cover or valve cover goes over, it's got a flat surface to seal against. The Ds do not have those half moons. Other differences, there's a webbing on the Bs here and here that the Ds do not have, but the Ds do have this additional passageway here, which is for the secondary air injection and links up to the exhaust port bowls down internally. There are other slight differences with the way the casting is and probably the internal water jacketing area. We can see down in here it's a lot deeper than it is on the Bs, but for the most part the heads function the same. I'm now going to discuss some of the changes I've made to the D25 heads when I've ported them. The first, and probably one of the largest changes I've made to the heads, is the inside seats of the valve seats. The inside diameter has been cut larger. I didn't do this personally, it was done at the shop. But if we look over on the B25 heads, on the intake, we can see that the inside diameter of the valve seat is about 29.5, just a smidge under. Going over to the D25 ones that I've had cut, that diameter is now out to 32 millimeters. So we've got a significant increase inside the diameter of the valve seat. Over on the exhaust, same thing. We can see the original diameter of the exhausts, inside diameter, is about 26, just a smidge over 26 millimeters. Onto the ones that have been cut, that diameter has now, get it in there, out to 28. So again, a significant increase in the diameter. In order to facilitate this, oversized valves will be used. I haven't currently got the valve seats cut to suit yet, only the inside diameter. That will happen once the porting is complete. But basically, the valves have a larger diameter on the seat. I think they're 1mm oversize. These ones we can see are 37mm, and the originals 36mm intakes. On the exhaust, the new valves 33mm, and the old ones, or the original spec ones, 32mm. These are Ferrero oversized Combustion Plus valves, and these are a set of Supertech standard replacement valves. So with the oversized valve, you're obviously allowing in more air once the seat has been cut to match. The other differences that I've done, I've gently smoothed and polished the combustion chamber surface. I could go a lot further and actually de-shroud around the valves, but I do not want to mess too much with the combustion chamber volume. Trying to get all four symmetricals an extra step of difficulty. It's a lot easier just to polish the surface, but if you really want to, you could, with this relief where it's been machined, just have the valve seats sunk into the combustion chamber. That can be smoothed out. You can also even open up this surface here, so that when the valves open, the air can come in better. But I mean, for now, I'll stick with that. The intake port runners, if we look over here, I've significantly opened up the intake ports. I've also port matched it to a phrenic spacer that will sit there. Obviously gaskets in between, but we have a nice smooth transition, rather than, if we look over on this one, it's not a perfect transition. We've got a gap around here, and in here where the fuel injector is, there's a steep ridge. So I've just blended that and smoothed it. Another key difference, if we look at my special 20-cent tool, so I've used to try and get consistency along the ports as I've ported them out. Cannot fit down the intake ports here. If we go over to the heads that I've ported, they are all ported to that diameter. I've just used that as a cheap homemade tool, knocked together with brake line, 20-cent piece welded together, that I can use to size the heads. I will also be CCing the intake port volume, and well, exhaust isn't as critical, but the intake port volume will be CC'd. Unfortunately, I can't do it now because I've just broken my barrette, but that would be another way I'm going to try and determine that all the intake ports are symmetrical and equally sized, by sizing the runners and CCing the port volume. Another feature, the splitter has been knife edged. It's for aluminium, it's actually surprisingly sharp. You can see on the original casting it's quite a dull, blunt edge. In the porting process I've opened that right out, but I've still kept the splitter there because, well, you need it there for structural strength of the cylinder head. It basically keeps the combustion chamber together. These cylinder heads, they look like a solid block of aluminium, but when you actually look at them, they are Swiss cheese. The coolant passages, the oil galleries, the exhaust and intake passageways, the open space, there is very little aluminium inside here, and for the most part they are just layers of thin aluminium just webbing together to give it its structure. Quite an intricate design, but I mean, once you start opening up this, you weaken the area, you take a lot of material out. If we look in here, for example, you can see there's only a few millimeters here, in there to the walls. Same deal on the inside of the water jacket here, or the water area inside the combustion chamber. there's also relatively thin aluminium between the two. So once you start porting it, that gets thinner and thinner, and you have to actually be very careful how thin you go before you structurally weaken the head. Looking into the bowls, they've obviously, once the valve seat has been cut, I've opened and smoothed the bowl. I've just tried to gently taper it, and I don't have any way of getting them consistent other than eyeball and feel and just carefully, methodically taking out material consistently along all 8 intake port and exhaust ports. If we look at the bowls of the original casting, it's not the smoothest. There's casting flash inside it. Some of them even have a step up into the valve seat. It's just not a. There's improvements to be had there. You can also see that during my porting process, the valve guides have been munched up. That's not a concern for me because they are going to be pressed out and replaced with new items. I've also, looking into the exhaust, you can see the mounds that reinforce that area. I've also smoothed and smoothed that area out and reduced its size to try and help there. The exhaust flange for the exhaust manifold. Now I haven't taken that right out to the gasket. I have enlarged it, but not to the point where it's at the gasket. I've tried to, as best I can, port match to my headers without getting a situation, because these don't have any. The only way that this gasket and the corresponding exhaust manifold flange locates to the head is via the studs, and there is actually slop in there, which can result in a situation, say, this is obviously extreme, but you'd have a large gap here and an overhang on here. So the exhaust manifold flange is a larger diameter than this slightly, so that however it places, it's not going to overhang and block the gap or cause a restriction or a step there. But looking back into the exhaust, there will, for the most part, all the way around be a slight lip. This isn't as critical as it would be for the intake. As long as it's a step up, not a step down, then it should be all right. Other changes that I've made to the head. Sorry, if we go back to the intake port flange, to try and get rid of that slop I was just discussing with the manifolds and the phrenic spacers. Subaru originally used 5mm roll pins. What I have done to try and help reduce a bit of that slop is I've actually pulled the pins out and I've drilled and tapped through an M6. It's basically a blind hole, so I've used a bottoming tap to get it down there. In place of the roll pins, the 5mm roll pins, I've gone up to a 6mm grub screw. So it's just another thing that we can do to take a bit of the slop out of that manifold and make sure that we have a nice smooth transition from manifold to phrenic spacer to the cylinder head. There is still slop there, but it's less than it is with the 5mm roll pins. I'm sure there is a better way of doing it. Maybe if you had very accurate tooling, you could perhaps put additional roll pins and make them a lot snugger, more precise fit. For me, I'm comfortable with this, and just as I put it together, care will be taken to ensure it all lines up. The exhausts, the Subaru have a very funny design with the exhaust port. If we look at this cylinder here, for example, this front cylinder, I think this is cylinder number 2, ports are here, flange for the exhaust manifold is here. It's a relatively straight flow for the ports. Going to the rear cylinder, it's totally opposite. We've got ports here, and there's basically inside the cylinder head there's a big dog leg and comes out there. The intakes, they line up. all of them are relatively symmetrical. I'd say they're probably made from the exact same casting when the cylinder head is made. Exhausts, weird dogleg, and if we look on the other cylinder head, the opposite side, it's the same situation. You've got one that's straight, one that has an internal dogleg. So trying to match those and get them symmetrical, and is basically, how do you do that when you've got a totally different design inside the cylinder head? What I've done with my porting, I've basically just taken a burr and enlarged all the areas, smoothed them, then gone down with my flat wheels and progressively got it smoother and smoother and smoother, and just a slight enlarge of the passageways, trying to do it as equal as I can. Looking down to the splitter, I haven't knifed edged it quite as much as I have the intakes, but that has been slendered down, smoothed, polished. So that's some of the differences I've made with the port work I've done to the cylinder heads. This is the first set of heads I've ported. I'm not an expert. I've basically done a bit of reading on the internet, had some advice from people that have done it before me, and I'm just going to hope for the best, basically. What I might do in the new year, if I have some time, I might take these heads down. If I can find a shop locally that has a flow bench, maybe might chuck them on there, try and make sure they're at least consistent and relatively all in the same ballpark. If they can make recommendations that there are changes to be made, then that can be done. I would just like to discuss the port sizing. On the original unported heads, looking down here, you can see I've actually got a valve retainer. This is just to give you a comparison of the diameter. The retainer, this particular one, measures in at 26.5 millimeter, and it can pretty much go down the port. Only ever so slightly snags up, probably because of the casting flash. I'd say that port diameter, if you're looking down there, it's pretty much going to be bang on 26.5, 27 millimeter. I don't know, thereabouts. If we go over to the one that I have ported, and get the light in there, hopefully that is a good shot. I'll get my special tool. As I said, I've taken them out to that diameter, basically just using that as a feeler, and working my way down, trying to get it as snug as I can to it. Now this 20-cent piece, it has a diameter, let me get that on there, of 28 millimeters. So I've gone from 26.5 up to 28, probably 29, 28.5 by the time I've got the clearance around the 20-cent piece. In terms of cross-sectional area, it's gone from, I've done the calculations already, it's probably approximately 550 square millimeters up to 660 square millimeters. So it's about a 20% increase in diameter going down the port, rough calculations. Porting, from what I understand, as I said, I'm not an expert, is all about getting air in and out of the engine, but you do not want to go so extreme that you sacrifice the velocity going down the ports, because that actually reduces volumetric efficiency and cylinder filling. I'd hazard a guess that when Subaru put these engines together, a lot of design went into the ports as it was, and they probably optimized it at a guess for maybe 3,000 to 4,000 RPM, or maybe that's a ballpark estimate, where they wanted it to be most efficient, because that's a typical car is going to be, that's when they're going to want the maybe 3,000 RPMs, highway cruising RPMs, thereabouts, typically not meant to be run out to high RPMs, and it's not a race engine straight out of the factory. Going higher RPMs, you want to be able to get the air in and out faster, or it's happening faster, so you need to get a larger volume of air through the port at the same time. So, I mean, I'm trying to optimize the higher RPM aspect of the engine, obviously very large cams, and the port work, the D-stroker engine. A lot of things are going into it to make it perform well in the higher RPMs. So by my uneducated reasoning, if Subaru have sort of aimed for a 3,000 to 4,000 RPM and I've increased that diameter, I'm shifting that efficiency where it's most efficient into the higher RPMs, without doing thousands of heads and building thousands of engines and logging all the differences and flow benching it and everything else. There's no real guaranteed way of knowing how it's going to affect things, but we can assume that increase in diameter there is going to shift towards a higher RPM benefit. Just trying to get some nice close-up shots of the port work. Hopefully this will focus and come out nice. You can see what I've done. Looking into the exhaust now. Did manage to get right into that deep corner of the dog-legged exhaust port and give that a burr and smooth. You can hardly even see it. Really steep angle getting in there. Don't know how that's going to turn out. We'll see on the video later. Other changes I've made to the cylinder heads. Because my car was never equipped with the secondary air injection system, the original head never had it, the vehicle never needed it. I'm going to these newer style heads and they do have the secondary air injection ports. So what I've done, I've basically run a 1/8 NPT tap, or drilled to the corresponding size and tapped out the thing so I can put a plug in it. It's just a nice easy way of blocking it off. A lot of people put plates on there, because I've had the heads apart and they're getting all the port work is going to need to be cleaned anyways, so I have no drama in tapping that. Nice cheap, I had the plug laying around, easy way of doing it. Other changes that I've made, if we look over to the other side, this is the driver's side. This would be typically where the standard oil drain return for the turbo is. My engine runs a low mount turbo, so I've taken the time and I've actually tapped that again, NPT, put it to a 1/2 inch NPT, and I can put a plug right into it. Also we can see the opposite side air injection, again 1/8 NPT tap, run through it to block that off. Nice shots down inside the intake runners. These ones haven't been polished yet. I'll run out of the felt wheels to polish, but they've all been sanded to the finest grit and basically ready for polishing. See a nice sharp knife edge there. Enlarged this area here. I haven't began smoothing out the entire side of the combustion chamber, but that's basically just a very light sand to take the casting mark off and then polishing it. Once all these have been done, the heads will be returned to the engine shop in Canning Vale, and Neil there will cut the valve seats all the way around to suit the oversized valves. For now he's only done the inside diameter, so then I can port it. Then once all that's done, all the burrs and stuff that could damage the valve seats are out of the way and that work is done, the valve seats can then be cut and then the valves are lapped in. One other thing I would like to discuss with the cylinder heads and the modifications to them. I plan to be using 14mm head studs, bolts, to secure the cylinder heads onto the engine block. So these will have to be drilled out to suit the larger diameter studs, and obviously the block will need to be drilled, tapped and whatnot to allow the studs to insert. This is done to secure the cylinder head onto the block with more force, I suppose, or stronger. There is people seem to think that the smaller diameter heads can stretch under big boost and big cylinder pressures. It's probably a combination of the bolts stretching and the cylinder head actually warping. As I said, these heads are like Swiss cheese. There is a lot of open space that you cannot see all through them. Oil drains, intake and exhausts, and coolant passages. So the whole thing is just a big sponge. There's a lot of air gaps in there, so I'm sure that it will flex, and that's possibly part of the reason why people do the larger cylinder heads or the stronger studs. I'm going 14s, and yeah, see what happens. Some extra changes I've also made to these heads. Where the buckets slide up and down, I have clearanced the leading and trailing edges so that the cam lobes can spin freely. I'm using very large high lift cams. They have something like 11.5 or 11.3 millimeters of lift. As such, I had to clearance the heads so that they could actually spin. The cams are the GSC S3 cams. As said, I've clearanced the buckets, the leading and trailing edges. I've also clearanced the lower edge of the cylinder head ever so slightly here and here, just to give clearance for the lobe. And I've also had to, if you look over on this other side, on the cam cap, there's a bridge between the front and middle cap. Here, this bridge has to be clearanced as well. This is probably the biggest one you have to do. If we look how it sits on the engine, you can see the front cam, the lobe spins here and it actually would foul. So that's another little change that I've made to facilitate that. I haven't done it yet, but the AVCS solenoids with these very large cams, I'm not actually running any AVCS automatic advance for the intake camshafts. So there will be special plug turned that can go in here to allow the oil to still lubricate the front journal, but not pass oil into the camshaft. Well, pass oil into the camshaft, but not alter the way the cam pulley will be advanced and retarded. The camshafts themselves, I've actually drilled and tapped the oil galleries in the front nose of the camshaft, and that's been plugged. So that's another little modification done to these heads. These are the cams, GSC Power Division S3, to suit the single AVCS 2.5 litre EJ motors. Open them up. Stay there, you bastard. See if we can find one. This is one of the intakes. I've already drilled and tapped the oil gallery that would then send oil to the AVCS pulley, the intake pulley, the sprocket. So what would typically happen is oil would be directed into either one of these two grooves via the solenoid. Solenoid directs the oil, it runs into here. Actually, sorry, that's the exhaust. It'll be one of these ones, the intakes. Feeds the oil into either there to advance and retard it. That oil travels down in these holes and it is fed into the pulley via these holes. Now what I've done is painstakingly drilled them out and tapped them for M5. and then put an M5 grub screw in there. Now these camshafts, billet construction, and they've got this black, I believe it's nitrate coating. So the surface hardness is very, very hard, and it gave me a great deal of trouble drilling and tapping these. Went through maybe 10 taps, broke many off inside there, and struggled with it for days trying to just to get these threads in there. The material was so hard it didn't actually cut any threads. It basically formed the threads. There was no chips or swarf come out. As the tap was forced down there, it almost rolled a thread. Very hard going, very hard on the tooling, but I got there. Bit of a close up. You can see I've just around the edges I've just touched it up with a little bit of a little diamond wheel or something to smooth off the ridges. And yeah, they're the little M5 grub screws. These cams are very, very large. I think they rated them at 282 degrees of duration. I think that's with 40 thou lift or 50 thou lift. So very, very long duration, and the lift as well. I think they have about 11.5 millimeters of camshaft lift, which equates to about 11.3 or thereabouts of valve lift, taking into consideration the clearance that you have between the lobes and the buckets. So very, very high lift, very, very large duration. I think the description on their website says they're good for 750 plus horsepower, and I think it was at 5 to 9 or 4.5 to 9,000 RPM. Big cams. I'm going to put them in, see what happens. Would also like to discuss the camshaft pulleys that I'm using. As I've mentioned previously, I'm doing a AVCS delete, which takes away the active valve control, or the intake only active valve control that the Subaru engines use. So in place of the heavy original pulleys are these Brian Crow BC pulleys, Vernier adjustable. There's 4 of them, obviously, you can see here. Yeah, just to replace the standard pulleys. I probably could have reused the intake AVCS ones with the plug that the plugs I've put into the cams. But the benefit of these is there is a massive weight saving for the intakes. The exhausts work out about the same, or fractionally heavier. But the intake ones are probably, I can't remember the weights offhand, but I think it works out about a third or a quarter, about a third I think, of what the Subaru pulleys weigh, just by going to this, which on an engine that's going to spin high RPMs, and you want you want to move it fast and spin it fast and that sort of stuff. I think that sort of rotating weight is it's all going to add up and help with that. No point having 2 kilo pulleys when you can put 500 gram pulleys on in place of them, and they look cool. I would also like to discuss manifolds. First up, intake manifold. This is not the original one to the car. This one is a 2009 onwards SH Forester with an EJ25, but the single cam non-turbo. I think it's single cam. The non-turbo version, anyways. The internet says these are a good manifold. Airflow coming from the plenum into the runners is sort of angled a bit better. The typical Subaru design basically has it coming out at 90 degree. These have a bit of a 45 in. Other benefits, Subaru for a long time had a sort of 2-part manifold, or 3-part manifold. There was a flange join here, and they would have these riser blocks that had valving and tumble valving and the injectors and whatnot. We had an additional join, This particular manifold is all one piece, less joins, less transitions. Some of the drawbacks are, obviously it's got, you can see I'm sort of halfway through removing it, there was some emissions rubbish that was here. There was some sort of valve block here and a port, I think it was the air injection or something like that. So I'm basically in the process right now. Looks like I've butchered it, but I'm going to basically just remove this pipe. I'm going to drill and tap and plug that, smooth off all this down to that. I'll probably remove a lot of the unused mounting threaded areas for stuff that I simply won't be using. So I'm going to basically smooth the manifold. That's purely aesthetics. It's not really going to help performance in any ways. You can see looking into where the cylinder head meets the intake manifold and the phenolic spaces. So these will be going there. That will be, I don't know if you can see that. Shift it over. That will be opened up, port matched. You can sort of almost see the mark where the gasket previously was on the original engine. So I'm basically just going to smooth that out. I'll try and get as much of the sand casting pattern on the inside as deep as I can smoothed, and I might slightly enlarge it if there's any meat to enlarge it with. And if this is going to be suited to a non-turbo engine, it's probably going to flow a volume that's going to make it efficient for a non-turbo engine at a typical street car RPM. Same principle with opening the ports on the cylinder head. I'll try and open these to try and shift that efficiency to a higher RPM, and yeah, just port match it. People have, because these are not meant to go on the twin cam turbo cylinder heads, what happens with these is when you put your fuel injectors in there and your fuel rail, it actually fouls on the AVCS solenoid, the connector, the plug for the solenoid. So people will typically use quite large spaces to space it up off the cylinder head, and you know, pick thin, slender fuel rails and whatnot. Basically, I'm not running AVCS, so that's not going to be a concern for me. As I said earlier, the AVCS solenoid, where the valve enters into it, will have a plug turned to go in there, and there will be no solenoid coil. The solenoid will be removed, and hopefully not have any fouling issues with the fuel rail onto the AVCS. Manifold will be forward spacing, so flipped from the standard backward spacing where the throttle body is. That's sort of getting out of the scope of the cylinder head, but I'd just like to discuss it. And this is my exhaust manifold, and this is one I actually built by hand with the TIG machine that you see over to the side there. Got some laser cut or CNC cut or whatever cut flanges, pre-built flanges off the internet, quite thick, and then steam pipe, stainless steel bends, pre-bought bends. It's all pipe. What is it, 1.5 inch nominal pipe, and I think it's schedule 10. It's a 4-into-1 design. Underneath this heat shielding and stuff, there's a 4-into-1 merge collector. Then it goes up to a 2-inch pipe for this section. There's a T-piece, that's basically the wastegate. Shoots off down there, external streamer gate. And turbo right here. So this basically, driver's side cylinder head is here. Turbo is more or less directly below it. Low mount turbo. As I said earlier, with the matching this flange to the exhaust port on the cylinder head, these holes, I think the standard diameter is a 10mm stud. These holes are at a 12 or maybe even a ½ inch. So what that means is when the studs are in there, there's a fair bit of slop. This whole flange can move around, you know, 1 or 2 mils every way, or 2.5 mils or whatever. So that is one of the reasons why I've not ported all the way out on the exhaust flange, and this I'm going to open up slightly, and I might even see if I can get some reducer spacers turned that go from that diameter to a perfect snug fit on the stud of the exhaust manifold stud to try and take out that slop. I don't know how that's going to go. I did actually try when I put them on originally. I had a piece of 1mm aluminium. I just rolled a little C-shaped sleeve, and that was good enough to get it sort of semi-located. But I might have to try and get it a bit snugger when it goes back together. I would like to discuss some of the tooling that I've used during the porting. First up, these cylinder head stands. I've got these during an order from Jegs in the United States. Probably could have made them myself, but they were relatively cheap and I was already getting stuff sent over. They come as pairs, and they basically work just like, if you can see this cylinder head over here. Put it into the head stud bolts and they stand up. This is very handy. This head's upside down right now, but it would allow me to remove the valve springs or the retainers and springs using the valve spring compressor. So you can get in from the bottom and the top, clamped together. They hold the heads up and they're a fairly stable thing. Also, if you're going to be doing combustion chamber CCing or such, you can stand them and balance them and then do that. You can probably see over here my barrette. I have a stand and clamp and whatnot for it, but this is just the measuring tube. Was one piece, now it's many pieces. It's a plastic one, which I thought would probably be not brittle like glass would be. Also cheaper to buy than the glass, cheaper to ship, sorry, than the glass ones. And unfortunately, I think I put the wrong chemical in here, and it basically turned the brittle within a few seconds. Very brittle. I was going to use ethanol and a bit of food colouring to get my fluid, but I put methylated spirits, thinking it'll be the same thing. Just a $3 jar of metho from Bunnings with a already blue tinge to it. It basically destroyed the tube instantly. But that would be a very handy tool for CCing the cylinder head combustion chambers, and also, as I explained earlier, trying to CC the intake ports to get a uniform across all cylinders. The actual porting itself, you're going to want safety glasses and a dust mask, especially when you get down to sanding. You definitely want, this is a cheapie, you probably want a better one. Given the amount of time you're going to be doing it, it's very time consuming, so you're going to spend a lot of time breathing in that shit. A good dust mask will definitely make your time more enjoyable. Couple of grinders, 1/4 inch grinders. You can get these in air. I just happen to use the Milwaukee electric ones. Big batteries if you're using electric, just because small batteries really don't last long, so the big batteries give you a lot of run time. I have 2 of them, the fuel and the regular, just because sometimes you want to have a burr and a flat wheel. You don't want to always be changing back and forth. You can have one with each. Now off to the burrs and the sanding wheels. You want a good selection of carbide burrs. Over here, this one's quite a long one. You can get them all different ends, but having a selection of long ones to get quite deep in there, and a good selection of the shorter ones. You can get single cut, double cut, all different shapes and sizes. You can pick them up relatively cheap on eBay. Definitely want a good selection of those. For the 1/4 inch grinder, sanding wheels as well, flat wheels. This is one's worn down. It would usually be a cylindrical shape, and these are just layers of sandpaper sort of glued together. There's an epoxy in there and they glue them together. This particular one's an 80 grit. You'd want a good selection of the 80s, and then maybe a finer grits after that. This is just for the rough bogging out. Most of the actual smoothing I've done on a Dremel. Again, using flat wheels. You can get all different types of sanding and buffing and grinding and different attachments for the Dremel. I personally found these mini flat wheels the best. You can get ones that are rolls of single piece of sandpaper. You can get ones that are just a cylindrical thing that you put a rubber expander into. Not as good as the flat wheels. In my opinion, these are the best. These particular ones, you can see it comes with a little mandrel It's a little thread, like M3 thread or something, and then they come pre-tapped. You know, you can buy them, probably 50 of them for about 20 bucks delivered straight out of China. Takes a while to get here, but if you're planning it out, you get a good selection. You want 80s, and you probably want maybe 240s or 320s maybe afterwards, and yeah, you probably want about 50 of each grit. I basically, the way I did it is I bogged out we're using the carbide burrs, quick sand of the larger 1/4 inch flat wheels, and then majority of the work was done with the Dremel, the 1/8 inch grinder. The Dremel's a 1/8 inch, and these little flat wheels. The Dremel itself, if we swing over here, it's a 240 volt Dremel. Don't know if you can see the entire thing, but basically I've got it up there, cable tied, just within reach when I'm sitting at the bench, power switch, and then this is highly recommended, is the flexible end for it. You can probably get non-Dremel branded ones, but I had a kit from years ago and it came with this. So you've got a flexible lead and a quite slender handpiece that you can get right down in there and manoeuvre. I've actually, looking at it, this used to have the grey rubber. I've taken the grey rubber off just to get it a bit more slender so I can get it right down in there. And there's a nut that sort of covers up the burr, the securing collet nut. So definitely want one of those if you're going to be doing it. And yeah, you just need time. I've taken fucking long time. This is probably at least a solid week. You probably want to set yourself a week of time to do it. You probably could have done it quicker if I had more aggressive sanding wheels. I sort of started with the relatively softer, smoother sanding wheels. If I had more aggressive wheels, I could have reduced that time, bogged out more material quicker, and then gone down to the smooth polishing. I don't have them with me now. As I said, I've used them all up, but also polishing wheels. So they'll look a little similar to this, with a little felt wheel. You can get some polishing rouge, and then you can just give these a polish, literally polish them. I have heard some people say that you want a rough finish, some people say you want a smooth finish, some people say you want it like a golf ball, lets the air through quicker. I'm not going to get right down into the science of it and what people prefer. I've done it smooth, not just because I think it's going to work well enough, also on engines, Subarus and stuff, any engine, the intake track, due to PCV systems and leaking turbos and all kinds of stuff, ends up full of oil, it gunks up, this carbon build up, this oil sludge build up, it sticks to all these rough edges. So sooner or later, even if you did get it a rough finish or a golf ball pattern finish or whatever, that will be before long gummed up with crap anyway. So I figure a smooth polished finish, probably less chance for that stuff to stick onto it, and the fuel will probably wash it off better. Don't know, it's just a theory. That's what I'm running with. I have heard in the exhaust side of the porting, you do want it polished smooth. Again, I've polished it smooth. The differences between it, I don't know. Again, it's probably very, very small differences, and everyone's got an opinion. That's what I've done, what I believe is going to be probably best. Thanks for watching.